Let's prove this identity. If you're still in high school, this may not be applicable for you. You can skip and go watch some other videos. If you did not subscribe to this channel, please do so. We upload every week new videos on different topics. Now, these are called trig identities. In order for us to prove this, what it basically means for us to prove, it means we need to show that what we have on the right hand side should be equal to what we have on the left hand side. Now, in order for us to do that, what we need to do, we rewrite that expression. We have sine theta plus tan theta over cosine theta plus 1 equals to tangent theta. Now we need to show that what we have this side is equal to what we have on the left hand side. Now in doing that, what we need to do, we have to rewrite tan theta in terms of sine and cosine. Then we are going to have, let me do this. Then we are going to have sine theta plus tan theta we know is sine theta over cosine theta. And then we divide that by cosine theta plus 1. Now, what we need to do here, we have to do something such that there should be something that should cancel out. Now, in order for us to do that, we need to divide top and bottom by cosine theta. It's like we're multiplying the whole expression by 1 so that we don't change everything that we have there. Now we're going to write cosine theta bracket sine theta plus sine theta over cosine theta in brackets, and then over cosine theta sine theta plus 1. Now what we can basically see here, we did not change anything. The expression that we have here is what we have in brackets. What we only did, we multiplied by 1. Cosine theta over cosine theta, that's equal to 1. Now what we can do here, we have to distribute this cosine theta with what we have inside the bracket. Then we are going to have cosine theta times sine theta. We are going to have sine theta cosine theta plus, when you multiply cosine theta by sine theta over cosine theta, this cosine theta will cancel, and then we are only left with sine theta. And then over the denominator, we just leave it the way it is. Cosine theta and then cosine theta plus 1. We are leaving the denominator the way it is because we want to factor out sine theta somewhere there. We have sine theta, we have sine theta, so we can take that as a common factor, and then we have sine theta outside the bracket, and then inside we have cosine theta plus 1 over, we can write what we have as the denominator, cosine theta and then cosine theta plus 1. You can see cosine theta plus 1, cosine theta plus 1. That these two will cancel. Now what we only have is sine theta over cosine theta. We can rewrite that this side. Sine theta over cosine theta. Now what you can see here, if you have sine theta over cosine theta, what you can see there, we had tan theta. We rewrite this tan theta in terms of sine theta over cosine theta. Therefore, we can write this as tan theta. Now, what you can see is that what we are getting here is exactly what we have there. Then we can now write that this is end of the proof. This is what we have on the left hand side. If you did not subscribe to this channel, please do so. We upload new videos every week on different topics.